Okay, ladies and gentlemen, here is the video that I mentioned that I was going to put up for you guys on the shortcut formula. Okay, so here's going to be what we do for the shortcut formula for the variance and standard deviation. Now, if I ever have to compute a variance or a standard deviation, I guarantee you I use the shortcut formula, ladies and gentlemen. Yes, you're going to love it. Highly recommend. This is the definition, by the way. These are the definition of the variance and the standard deviation. So if you guys remember some of those things, these are definitions. Okay, now, shortcut. Here we go. This is what I recommend you guys do. Variance formula. Now, variance again, the symbol for variance or for a sample variance is s squared. And so you start really with the variance formula, n sum x squared minus sum x in parentheses squared over n times n minus 1. So, ladies and gentlemen, the variance formula here, which is really s squared, this is your shortcut. Believe it or not, I'm going to put this in words here. This is called a shortcut. And once you get the variance, the standard deviation is square root of that variance. And remember, the symbol for standard deviation, sample standard deviation, is s. So what we're really saying is s is the square root of s squared. This is what this means in words. Okay, you guys okay with that? So this, believe it or not, is in fact the shortcut formula. And this is what I recommend you guys use. And I can't recommend it enough. Now, you may look at this and you say, you know, Mr. Judge, I don't know if that's a shortcut. Well, it is a shortcut. Let's go back to some data. I'm going to go back to the data of sleep. Let's get to the sleep data. This is the Miley data. And I think we had some sleep data somewhere. The original sleep data. And we're going to go back and get the original. There's the original data here. Okay, we're going to copy it. There's the original data. We're going to copy it. We're going to bring it down. And I'm going to show you exactly how this works. Okay? So remember, data is represented by an arbitrary x value. This is what we're talking about. It's a variable that just holds those values, 7, 8, and so on, right? And what I'll do here is I'll put a column. So we create a column, we create a next column here. 7, 8, 8, 5, 5, 5, 8, 9, 7, and 2 5s here. Okay? Your data does not have to be in order, but that's the x column. This is where you start. So you just list your data here. And then finally here, we're going to take an x squared column here. Okay, so once I get the data, we're going to square that data. And then you might say, well, why do I do this? Because remember, go back over here to the shortcut. N is the sample size. You know that already, n. And we just counted. And if you remember, let's double check. N was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the sample size here is 11. So in the shortcut formula, we already know, put an 11 here, put an 11 here, and an 11 here in the shortcut formula. what you're going to need to determine is two things now. We need the sum of the x squared values. We need here the sum of the x values. And then don't forget there's a little power 2. So we're going to have to talk about that kind of notation here. So in green, though, the sum of the x values, we're going to need to add the x values like we did before. We're going to add those. This will be the sum of the x values. And we already know that sum. And you say, what do you mean? See, when they ask you for the variance and the standard deviation, they're going to ask you for the mean as well. And so the reason that's a shortcut is if you computed the mean, and you have half the information already. So you go, oh, okay, sum x, go back in our notes and for class again, sum x, where was it? We computed the mean. There it is. Sum x right in here, it was 72. 72, we added the x values. See, sample size is 11. So 72 is that sum. Sum x is 72. We added the data. So we already had that. Now you might say, do we really have it? Yeah, we have it. I mean, if you want to double check some of that x values here, we added them. You know, if you want to double check, you certainly can. And I guess I'll paint it green here because it's green in our formula there. We're adding that column. And we get this 72 here. So if you said, I don't remember that, okay, well, go to the TI then. And in the TI, here you want to use it. You're going to take the first data value. So go back to the data value, right? Say, okay, I have a 7 and then an 8. There's 2 8s and then 3 5s. So we're going to start to add those numbers. 7 plus 8 plus 8 plus 5 and another 5 and another 5. There were 3 5s. Plus 8 plus 9 plus 7 plus 5 plus another 5. And ladies and gentlemen, yes, we did get 72. So sure enough, like we did the other day in class, yes, that sum is in fact 72. So this is my sum x value. So I want to let you guys know that number typically you already have. 72 goes right in here. This is where 72 would be. That's sum x. So we say, oh, great. Okay, well, that's where it comes from. And then now notice what we have here. We need in orange now, sum x squared. We need this information. And so that's where another column is created. So this only has 2 columns. So we need the x squared column. And to get the x squared column, we have to take every x value. Here's the first one. It was 7 right over here. You guys remember that? You square that. The next x value is 8. You square that. Another 8, you square it. 5, you square it. 5, you square it. So square all the x values, ladies and gentlemen. So in the next x value is an 8. We're going to square the 8. A 9, we're going to square the 9. We square the 7. We square the 5. And ladies and gentlemen, this is how you proceed to get those x squared values. Now, I know these numbers. 7 squared is 49. It's multiplication. 8 squared, 64. Here's still 64. 5 squared is 25. We know these. 64. 81, 49, 25, and another 25. These, ladies and gentlemen, are the x squared values, okay? But we need to sum all of these values. We need to add them. So I'm going to have to add all those values. And when we add all those values, ladies and gentlemen, that's going to be called sum of the x squared values. This is what we're looking for. Okay, so that's what's happening here. So let's, there we go. Let's add these numbers. Now you say, well, how do I add them? Well, you're going to go back to your TI or any calculator that you have. So add them. You say, okay, 49 plus 64 plus 64. 3 25s plus 64 plus 81 plus 49 plus 25 plus 25. And ladies and gentlemen, the sum is supposed to be 496. So here's going to be 496. Now we're going to double check this, by the way. We're going to double check this. So I'm going to say, okay, 496. So we got this value. Sum of the x squared values equals 496. I'm going to notate that. And I'm going to use that. Okay, 496 is going to go here in our formula here. Okay, so we're going to double check this information. But so far, we got the orange value. And so what I do, ladies and gentlemen, whenever I compute this, I'm going to do this here. I'm going to copy it. Bring it down. And what I do is I write it all again. This is what I mean. I want to be clear with what this is. This is 11 times, and that was 496. So it looks like we didn't get it all down there. 11 times 496 minus 72. Don't forget, that's to the second power here in our formula. So we're going to put that second power, that's in the numerator. And then this is 11 times. Now, what I do automatically is I say, oh, 11 minus 1. That's 1 fewer than 11. 11 minus 1, 1 fewer. And that's going to be 10. So just to kind of emphasize again in red, this is sample size. We got the orange value right here. And we got the green value right in here. That's where most of the work is going to be, is adding the data right here. We have to add the data to get that value, square those data values, and then add those. And that's going to get the sum x squared. And we did that. And ladies and gentlemen, now we're ready to find the variance. Now we're going to approximate this to the hundredths, I believe. Let's try, let's do the tenths. Okay, we're going to approximate this to the tenths, but what you guys see here is a fraction. So for your fraction, you have a numerator divided by a denominator. So I'm going to put these parentheses in case you're using a calculator that requires you to do one or to use one. And let's see what this gives us. So here's a parentheses. This is what I'm saying. 11 times 496 minus 72 to the second power, close that parentheses, divided by 11 times 10, and you close that as well. Double check. Double check your work. 11 times 496 minus 72 squared. All right, looks good. Looks good. Okay, now hit enter. And we'll approximate this to the tenths. So, or no, let's do hundredths. I apologize for. We're going to do hundredths here. We're going to take a look at that. Okay. Hundredths. So when I write this down, if you guys remember, this is 2.47272 and 72 The hundredths now is in, let's check. We got the tenths, we got the hundredths position. We look at the digit to the right, and the digit to the right, ladies and gentlemen, is a 2. So that digit to the right of the 7 in the hundredths position is a 2. That means we leave the 7 alone, ladies and gentlemen. Remember, if it's a 0, 1, 2, 3, or 4, we leave it alone. Our variance is going to be 2.47 hours. And I keep the units because that's what this represents, 2.47 hours. This is your variance. It's the shortcut formula. So if I go back and we say, okay, how do we get then the standard deviation? Well, once you get this variance, I'm going to erase all this. But once you get the variance, ladies and gentlemen, you're going to get the standard deviation. All you do is take, here's the variance. Here's the variance. You take the square root. You take the square root. It's a variance, s squared, sample variance. So you say, all I have to do now to get that standard deviation, take that square root of this number here, and I'll say, yes, take the square root of that prior, more accurate number. So in the calculator, it remembers your prior answer. So I just have to say in the TI, hit second square root. And then I got to go in blue, this lower corner in the right corner here, hit second, right? This key right here in the lower right corner. It's the answer key. What that does is it remembers the prior answer. Now, 2.4727272723 is more accurate than the 2.47. So we're going to use the prior answer. And ladies and gentlemen, you're going to now get the standard deviation. And this will approximate to the hundredths as well. So I have 1.572490786. And if I go to the TI, remember prior answer is really the variance right here. But we're going to approximate this answer to the tenths. Sorry, hundredths. Tenths, hundredths. The digit to the right is a 2. We leave the 7 alone. Ladies and gentlemen, standard deviation, we're computing to be approximately 1.57. And that's also in hours. So ladies and gentlemen, this is how consistent our data set is. Okay? We just found the standard deviation as well by the shortcut formula. Now, remember I said we're going to double check. So what I'm going to do here is this. This is what I'm going to do. I'm going to go over to Microsoft Excel. And there's a good reason why I'm going to do that. You don't have to use Excel at all to answer these questions here. You use the TI like I just showed you. I just have as for demonstration purposes. I demonstrate. For demonstration purposes, here's my X. This is my data values. This is going to be the sleep data. Remember, I'm just going to double check all of this. This is for sleep. And ladies and gentlemen, we're going to enter the data values. You say, where do we get those data values? That's all the data that we already had here, right? This is these data values we have. Okay, so in the TI now, or not sorry, the TI, in Microsoft, I'm going to put these data values there and enter them. 7, 8, 8, 3 5s, 8, 9, 7, 5, and 5. Okay? This is the sleep data. And I'm going to put a column here labeled sum. And to sum, I'm going to sum my data values. Okay, so I'm going to add all of these data values. And then I think something happened here. Let's undo that. I'm going to undo it. No, don't want to do that. Sorry. In this field there, I'm going to sum these data values. So that sum was 72, like we thought it would be. All right. And then I have this x raised to the second power. That's what I want to do as well. I'm going to bold that. And what I'm going to do, I say equal, hit that cell, caret key, raising to a power. That's a caret key, raising to the second power. And we get 49. So I can do that. Now, the reason I like demonstrating in Microsoft Excel is because in the lower right corner, I do this cross there, right? I get there, get in the lower right corner, click and drag. That squares all the x values that we have. And so you can say, wow, that actually squares everything automatically. And I say, yes, it does. And that's a good thing. So now we can add to get this sum. And sure enough, we did get 496. So remember, this was the green value. This was the sum, and I'll paint it green. And then this was the orange value. Oops. Wrong one. Let's find orange. Oh, maybe there's orange. There it is. And ladies and gentlemen, this is what we're looking for. And this is, if we go back to the iPad, where are you, iPad? These are the values we found in green and orange. And this is how we use the shortcut formula. Okay. Now, I bring this up only because we're going to verify. I'm going to use the shortcut formula again to verify work we already did. In blue, remember in lecture, we got bowling scores. Well, I guess let's be careful. Not in blue. Well, we're going to have to change these colors here. Okay. Well, I guess we can go back. Whatever. Orange was Miley Cyrus's bowling scores. So if you guys remember Miley Cyrus's bowling scores, we're going to verify the work we did already from Miley Cyrus. And I'm going to change the colors, ladies and gentlemen. Okay. Whatever. N is 6. So we're going to use these values here now. We're going to verify. Let me just do the same thing for Hannah. So remember, we have all this information for Hannah. Let's just copy this. And we already did that. Her variance was 1700. Standard deviation is 41.23. So we're going to use the shortcut formula. So I want to verify the shortcut formula for, the bowling scores from Miley Cyrus. Okay. Now remember, these are x values. Once you gather your data, you got the x values. We're going to have to square the x values. And then we get some x squared. We know n was 6 for our sample size. We're going to see another example of this. Shortcut formula. So go over here, and I think this is Miley, so I'm going to label this Miley now. I'm going to do the work in Excel to show you how quick and fast that can be as a demonstration. But, you could use your calculator. No requirement that you have Microsoft Excel. So, ladies and gentlemen, the first score, 185. Okay? The second score, 150. 220. 185. 130. 240. And then I'll put a column here. Let's put the sum column. Okay? So we need the sum of the scores. We're going to put it right here. And there it is. This is the sum. So in green, this is why I had to say let's change the colors so that people can be consistent there. So that's what we need. We added these values. This is the sum of the x values. Now we have to square those x values. So put equal, put this value here, raise it to the second power. And sometimes, you know, I think we're good with the size. Well, that's 185 squared, by the way. We're going to square all the other x values. And there you go. So you get to square those x values too. Try that out in your calculators. Verify that these are the x squared values. Okay, so try that out. Now, add these particular values here. And you have obtained now in orange today, the orange for today, some x squared as well. And that's from Miley Cyrus. So now you say, well, what do we do with this information? So I'm going to do this here. Right? Let's go back to the iPad. What we found, sum of the x values, 1,110. We found sum of the x squared values, 213,850. So that the variance now is n sum x squared minus sum x in parentheses squared over n times n minus 1. Okay? Don't forget, sample size n was 6. So we have now, in orange, what we need. In green, what we need, we have the sample size here. N is 6. So just plug everything in. 6, 6, 6 minus 1. 2,000 or 213,000. Okay. 850. And then 1,110. This goes right in here, orange. The green, right in here. 6, here, here, and here. And don't forget, there's a square out here. Okay, so what I do personally, I will always write down variance 6 times 213,850 minus 1,110 to the second power over 6 times. Now I'll do some arithmetic here. This portion right here, I'll do that arithmetic. 6 minus 1 right in here, ladies and gentlemen, is 5. So that's why I got the 5 down there. Okay? So we get to enter this now in our TI calculator. And let's approximate to the same approximation that we did for this calculation, for variance, the other day. You say, well, what do we do? We already did this one. And we go all the way back, look at our notes. We went to the hundredths as well, 41.23. Or the variance was 1,700. Standard deviation is 41.23. So we're computing the variance. This is a variance formula. And then we'll take the square root to get standard deviation, ladies and gentlemen. We're going to go to the hundredths position now. So let's try this out in the TI now. We'll clear it and say, okay, parentheses, 6 times 213,850 minus 1,110. You raise that to the second power and you close this. Divide by 6 times 5 and you close that. And ladies and gentlemen, let's take a look here. Sure enough, the variance was or is 1,700. Okay, that's what we got before. All right, so there's our variance, and it's a whole number, so we don't, it's a whole number, so we put 1,700. Now remember, to get the standard deviation, we're going to take the square root of the variance because that's what that is. So I'm going to put equals because that's a whole number now. In fact, this we didn't approximate, so we're going to say this equals. So that's nice. It's exactly 1700. Okay, the mathematician, we're going to actually, in me, requires the equal. So square root of 1700, if we go to the TI, right, get the standard deviation, hit second, square root, second again, answer, because that keeps the prior answer in its memory. And what you'll do now is hit enter, and sure enough, 41.2310566. We approximate this again to the nearest hundredths, tenths, hundredths. We're looking at the digit to the right here. It's a 1, so it looks like we leave the 3 alone. So we get 41.23. And ladies and gentlemen, there you go. Let's verify that this is exactly what we got the other day. 41.23. And sure enough, it sure is. So let me actually move this here for us. Okay. So you guys can see. It's right over here. Let's move this. This was from Miley. And then this portion down here was for Hannah. Okay, so let's remember those things. So we verified today that the variance was 1700, standard deviation was 41.23 by the shortcut formula. And then, ladies and gentlemen, here's what I'm going to do. I'm going to ask you guys to do the following. I'm going to ask you guys now, on your own. This is Hannah's bowling scores. Those are the X values. So what I'm going to do now is I'm going to ask you guys to use the shortcut formula to verify that the variance is 290 and the standard deviation is 17.03, approximated to the nearest hundredths position. And this is again for Hannah, Montana. So you get to see and verify. So verify in gold here, if we can get this to be matching in some way. Verify in gold that these are actually correct. Again, using not the definitions, because these were definitions, but using the shortcut formula here, ladies and gentlemen. I want you guys to verify those bowling scores. So, yeah, this is what we do. And so, ladies and gentlemen, if we look at the Microsoft Excel here, you know, this is a shortcut. This is a shortcut. So, Hannah has scores just to get you started, right? So you say, okay, Mr. Judge, what do I do again? We need the X values. We need X to the second power. X is your data values. Okay, so you need those values here. And so you got to go back to the data for Hannah. This is for Hannah's bowling scores: 185, 210, 160, 175, 195, and 185. Okay? You go there. And let's get you started. Oh my God, Mr. Judge. Look at that. I'm going to add them. I'm going to get you guys even started on this. Shouldn't. I'm going to get you guys there. X to the second power. Square all those X values. And sure enough, ladies and gentlemen, there you go. Rather quickly, you have in orange what you need, and you have in green what you need. Verify now for Hannah that she has the appropriate variance and standard deviation we got by using the definition. So you have those values there already. Try that out, ladies and gentlemen. Try out the shortcut formula. And believe it or not, the shortcut formula is here to save your life. It is quicker because remember, you already needed to get the sum x values to compute the mean. So there you go, ladies and gentlemen. I'm going to leave you with that. Hope you guys have a great day. Take care, stay safe, and talk to you guys later.